Something at the edge of our solar system is pulling on objects, quietly, steadily, in a pattern that should not exist if the solar system is as complete as we thought it was. Astronomers noticed it years ago. They have been studying it carefully ever since. And what the evidence is pointing toward is something that, if confirmed, would be one of the most significant discoveries in the history of astronomy. This video is going to take you through the whole story. What is being observed, what scientists think is causing it, what the newest evidence shows, and why this question is still open. All of it is real science. None of it is settled yet. And that is precisely what makes it worth understanding. Let's take it step by step. First, let's understand the place in space where this mystery lives. Beyond Neptune, the farthest of the 8 known planets, there is a vast region called the Kuiper Belt. It is an enormous ring of icy bodies, frozen rocks, and small worlds that circles the outer solar system, beginning roughly 2.8 billion miles from the Sun and stretching outward from there. Pluto lives in the Kuiper Belt. So do hundreds of other smaller objects that have been discovered over the past few decades, many of them given temporary names and catalog numbers because there are simply too many to name individually. For a long time, astronomers assumed these objects orbited the Sun in a fairly random, spread-out fashion. Physics dictates that in the absence of any strong gravitational influence pushing them in a specific direction, the farthest points of their orbits should be distributed around the sky in all directions, like spokes on a wheel, pointing every which way. That is not what astronomers found when they began carefully mapping the most distant of these objects. In 2016, 2 astronomers at the California Institute of Technology, Konstantin Batygin and Mike Brown, published research that caught the attention of the entire planetary science community. They had been studying the orbits of 6 of the most distant known objects in the Kuiper Belt. These objects orbit so far from the Sun that some of them take tens of thousands of years to complete a single orbit. And when Batygin and Brown looked carefully at the farthest points of those 6 orbits, the points where each object swings out to its maximum distance from the Sun, all 6 were pointing in the same general direction. Not approximately, not roughly. The 6 most distant known objects in the solar system with orbits exclusively beyond Neptune all mysteriously line up in a single direction. Also, when viewed in 3 dimensions, they tilt nearly identically away from the plane of the solar system. The odds of that happening by chance? About 0.007%. That is less than 1 chance in 10,000. When something in nature produces a pattern that improbable, the scientific response is to ask what is causing it. Random chance becomes an unsatisfying answer when the probability of coincidence is that small. Batygin and Brown ran detailed computer simulations. They tried to find what configuration of the solar system could produce this clustering. And what their simulations consistently pointed to was a single explanation. A planet with 10 times the mass of Earth in a distant eccentric orbit, anti-aligned with the other 6 objects, is required to maintain this configuration. Something large, something distant, something with enough gravitational influence to organize the orbits of objects scattered across billions of miles of space into a recognizable pattern. They called it Planet 9. Now, before going further, it is important to be clear about what Planet 9 is and what it is not. Planet 9 has not been directly observed. Nobody has taken a photograph of it. No telescope has detected its light. What exists is mathematical and observational evidence. Patterns in the orbits of known objects that are difficult to explain without invoking the gravitational influence of something large and unseen. This is not unusual in the history of astronomy. Neptune itself was discovered this way. In the 19th century, astronomers noticed that Uranus was not following the orbital path that physics predicted for it. Something was tugging on it. They calculated where that something should be, pointed their telescopes at that location, and found Neptune exactly where the math said it would be. The Planet 9 hypothesis is following the same logic. The question is whether the logic is correct in this case. So what does the evidence actually say about what this object might be, if it exists? Planet 9 has a mass about 10 times that of Earth and orbits about 20 times farther from the Sun on average than does Neptune, which orbits the Sun at an average distance of 2.8 billion miles. It would take this planet between 10,000 and 20,000 years to make just one full orbit around the Sun. To put that distance in perspective, the Earth is 1 astronomical unit from the Sun, 1 AU. Neptune is about 30 AU. Planet 9, if it exists, is estimated to be somewhere between 400 and 800 AU from the Sun. That is between 400 and 800 times the distance from Earth to the Sun. At that distance, even a large planet reflects very little sunlight back toward us. It would reflect only a faint glimmer of sunlight. This makes it hard to detect using normal telescopes, especially in visible light. As one astronomer at the University of Pennsylvania put it, "It is pretty amazing to think that something as big as Neptune could be sitting out there and no one would have ever noticed it. But if you put it far enough away, it gets fainter and fainter very fast." This is the fundamental challenge. The object is not necessarily small. It may simply be extraordinarily far away. The evidence has continued to build since 2016. More distant Kuiper Belt objects have been discovered and added to the analysis. Each one that fits the predicted pattern strengthens the case. Each one that does not fit raises questions. While astronomers and space scientists were initially skeptical about the Planet 9 theory, there has been mounting evidence, thanks to increasingly powerful observations, that the orbits of trans-Neptunian objects are indeed erratic. One of the objects that the Planet 9 hypothesis helps explain particularly well is Sedna. Sedna is a reddish, distant world discovered in 2003 that has one of the most unusual orbits of anything in the solar system. At its farthest point, it travels over 900 AU from the Sun. At its closest, it never comes within Neptune's gravitational influence. It is, in a sense, hanging out there in space, disconnected from the usual gravitational dynamics of the outer solar system. Planet 9's existence helps explain more than just the alignment of distant Kuiper Belt objects. It provides an explanation for the mysterious orbits that Sedna traces. Bedigen and Brown found that the presence of Planet 9 in its proposed orbit naturally produces Sedna-like objects by taking a standard Kuiper Belt object and slowly pulling it away into an orbit less connected to Neptune. Sedna needed an explanation. Planet 9 provides one. That does not prove Planet 9 exists, but it means the hypothesis is doing useful scientific work, explaining things that otherwise have no clear explanation. Then in 2025, something happened that moved the search forward in a concrete way. A team of astronomers led by Terry Long Fan at National Tsinghua University in Taiwan went back into the archives. They looked at data from two different infrared sky surveys, one conducted by a satellite called IRES in 1983, and another by a Japanese satellite called Akari in 2006. These surveys were taken 23 years apart. The idea was straightforward. If a large, distant planet exists, it would be moving, very slowly, given how far it is, but measurably. By comparing the same patch of sky across a 23-year gap, you might catch something that shifted position slightly between the two surveys, in a way consistent with the slow movement of a distant planet. This careful search led the team to a single object, a tiny dot in the infrared data. It appears in one position in the 1983 image and in a slightly different position in the 2006 image. Researchers at the university believe a Neptune-sized object could be wandering roughly 46.5 to 65.1 billion miles from the Sun. Their findings are based on two deep infrared surveys taken more than 2 decades apart, with equipment sensitive enough to detect a faint planetary glow. If this object is what they think it might be, its estimated mass would be somewhere between 7 and 17 times that of Earth. That places it in the category of an ice giant, similar in character to Uranus or Neptune, rather than a rocky world like Earth. The team's findings were accepted for publication in the publications of the Astronomical Society of Australia. But here's the part that separates good science from wishful thinking, and it is worth taking a moment to explain it clearly. Not everyone is convinced. The candidate is simply a curious dot across a few infrared images. But the dot seemed to be moving in a way consistent with a large, distant planet. Seeming consistent is not the same as confirmed. Other astronomers have pointed out that the same infrared data has produced false candidates before. The surveys from 1983 and 2006 were not originally designed to search for Planet 9. They have gaps in coverage, varying sensitivities, and potential for instrumental artifacts that could mimic the signature of a slow-moving, distant object. There is also a broader debate in the astronomical community about whether the orbital clustering that started this whole discussion is as statistically significant as it first appeared. Some researchers argue that observational bias, the fact that certain parts of the sky are easier to survey than others, may have made the clustering look more pronounced than it truly is. If we are systematically finding more objects in certain directions because those directions are easier to observe, the pattern in the data may be partly a reflection of where we looked, rather than where the objects actually are. New discoveries of objects in the Kuiper Belt have also presented challenges for the Planet 9 theory. Some recently discovered objects have orbits that do not fit the predicted pattern as neatly as the original 6. Then there is a newer and separate hypothesis entirely. In late 2025, a Princeton astrophysicist named Amir Siraj published research proposing that the orbital anomalies in the outer solar system might be caused by a different object altogether, smaller and closer than Planet 9. He called it Planet Y. Planet Y is most likely a Mercury to Earth mass body, approximately 100 to 200 times the Earth-Sun distance, tilted at least 10 degrees relative to the other planets. It was quite a surprise to find that beyond about 80 times the Earth-Sun distance, the solar system suddenly appears to be tilted by about 15 degrees, and this is what sparked the Planet Y hypothesis. Planet 9 and Planet Y are not mutually exclusive, and they could both exist. This is where the science stands right now. Multiple hypotheses, multiple candidates, multiple lines of evidence that are suggestive but not conclusive, and genuine disagreement among careful, serious scientists about what it all means. The good news is that the answer may not be far off. The Vera C. Rubin Observatory in Chile will conduct a comprehensive all-sky survey that could provide crucial data to pinpoint Planet 9's location. With its powerful telescope, the observatory will be able to track thousands of trans-Neptunian objects and other distant objects, helping astronomers determine whether Planet 9 truly exists or if the observed anomalies are due to other factors. The Rubin Observatory is now operational. Over the next several years, it will produce a catalog of the outer solar system more complete than anything assembled before. Every faint object, every slow-moving dot, every candidate that might be a planet will be compared across multiple observations in multiple wavelengths, with the precision needed to tell a real discovery from an artifact of older, less capable instruments. The search for Planet 9 is a heated debate in astronomy. But we are so lucky to be living at a time when these discoveries might be made. That is a sentiment worth sitting with. The question of whether our solar system has a large, unknown world at its outer edge, a world larger than Earth, orbiting the sun so slowly that 1 year there equals 10,000 or 20,000 of ours, so distant and cold that it glows only faintly in infrared light. That question may be answered within the next few years. Not by speculation, not by inference from orbital patterns alone, but by direct observation. A telescope seeing it, a dot moving against the stars, an orbit calculated, a planet confirmed, or not confirmed, and the search continuing, with the mystery deepening. Either outcome advances our understanding of the solar system we live in. Either outcome is worth knowing. If this kind of careful, unhurried science is something you enjoy thinking about, subscribe and share this video with someone who would appreciate it. There is more of this story to come. Thank you for watching.